Good afternoon, everyone. So today I'll discuss about the Dijkstra's algorithm, that is the lab program. So before I'll move on to that Dijkstra's algorithm, just I will revise what is that Dijkstra concept. So Dijkstra algorithm is an algorithm which will always find the shortest distance from the given source vertex to all other vertices. From the given source vertex to all other vertices. So for example, you consider this particular graph and let us consider the source vertex as an A. Now from the A to the B the distance is 3 and to the C the distance is infinity because there is no path from A to the C. Therefore it is infinity. There is no distance from A to C, so its distance is an infinity. Like that you write down from the source vertex to all other vertices what is the distance you are having. Now I told you while explaining about the algorithm of the Dijkstra, then what is the next step you are going to do? You are going to find out the U and D of U such that the U should be an unvisited vertex. It should be closest to the recently visited vertex, and D of U should be an minimum. U should be an unvisited vertex. D of U should be an minimum distance vertex. Okay. So that is what is U and the D of U. So here I'll find out here what is D of U, which is a minimum, that is 3. So D of U is 3. U is B. U is B. D of U is 3. So I got U and the D of U. Okay, once I'll get to the U and D of U, next what you have to do is you make that particular vertex as an tree vertex. That means I am selecting that particular edge. A to B is selected. A to B is selected. So I am making that as a selected vertex. Now through B, can I reduce any of the distance? That you need to check afterwards. After finding out the U and D of U, don't stop over there. You need to find out through that U, can I reduce the previous distance to the unvisited vertices? So which are the unvisited vertex? D, C, E. What is the previous distance to the D? A to D was 7. Previous distance to the C was infinity because there was no distance from A to C, and to the E also it is infinity. Now through B, so I can find the distance to the C. Initially A to C was infinity, but through B, which is the recent U, I can reduce the distance from A to C as an 7. 3 plus 4. Initially it was the distance to the B was distance to the C was infinity. Now I am reducing it to the 3 plus 4, that is 7. Okay. Now to the D, through initially the distance from A to D was 7, but through B if I'll go, it is 5. Through B if I'll go, it is 5. So that is also updated here. Initially the distance from A to D was 7. The distance from A to D was 7. Now through B if I'll go, it is 5. 3 plus 2 is 5. Okay. And E. To the E, I am not having a distance from B to E. We are not having a distance from B to E. So let it be an same thing. So it is infinity only. There is no change. After that again repeat the same thing. Now among this, identify the U and D of U such that the U should be an unvisited vertex and D of U should be an minimum. So all are unvisited vertex. C, D and the E. All three are unvisited vertices. So which is the minimum? 7, 5. So 5 is the minimum. So next vertex what you are selecting is the D. So it is U. What is D of U? It is nothing but the 5. Now through this D, can I reduce the further distance? You check. Okay. Through D, I can reduce any other distance. You check. What is the previous distance to the C? Only to the unvisited vertex you need to check. Unvisited vertices are now only C and the E. Only these two are the unvisited vertex you are having. Okay. Through D, what is the previous distance to the C? 7. And through D if I'll go, it is more. Okay, no need of changing that. And what is the previous distance to the E? Infinity. Through D, if I'll go, what is the distance to the D? 3 plus 2, 5. 5, okay, plus 4, it is 9. Getting my point? So, to the C, previous distance was 7. If I'll go through this, it is 5 plus 5, 10. So, 7 is lesser than the 10. Therefore, I'll keep the distance same thing only. Whatever previous was there, I'll keep the same distance. But this distance I am changing now. So, like that, in the each iteration, you need to find out the u and the d of the u such that the d of u should be minimum and u should be an unvisited vertex. So just I have revised the concept of an Dijkstra's algorithm. Now we will see that that is the algorithm. So this is your 7th program, lab program. For a given vertex in a weighted connected graph, so it should be weighted, weight should be there, otherwise you cannot find out the minimum path, and the graph should be an connected graph. For an unconnected graph, you cannot find out the shortest path. So for a weighted connected graph, I need to find out the shortest path to other vertices. Okay, means from the source vertex to the from a given vertex, means source vertex, I need to find out the shortest path to the other vertices using an Dijkstra's algorithm, and whatever the program you are writing, write it in a Java. Now come to the these are the declaration thing what you are doing. I hear the size of the array max they have declared as 20, but usually don't go for a 20. You can keep it as a 10. It is more than enough. Then you are considering one more variable called as a infinity. So 9999. Why we are using this 49 here is, so we cannot write that symbol infinity. Whenever the distance is not there from any vertex to the any other vertex, the distance is infinity. But we cannot write it as a infinity symbol. That is the reason you usually will take it as 39 or 49 or 59, which indicate that a higher value. Okay, it indicate that it is a infinity. Then n represent the number of the vertices in a given graph, and A is nothing but your cost adjacency matrix, where you will be representing what is the cost from 1 to 1, 1 to 2, 1 to 3, like that. Okay, so that is the declarations what you are doing. Then you are having your main program. This is your main program. So in the main program, initially we are calling the matrix called as a read matrix. In the read matrix, you are not doing anything, just you are reading the matrix. And initially the starting vertex is considered as a 0. If you want, you can keep this step, otherwise not required. Anyhow, we are entering the starting vertex here. By default, it is an 0th vertex. Otherwise, you can read it. Any vertex can be taken as an source vertex. It is not compulsory that the A or the node 1 should be the start vertex. Node 5 can also be a start vertex. So, we are reading the starting vertex.